that still holds. Please enjoy this talk. I know I will. Give a warm welcome to Chris.
Good morning, everyone. Thank you for attending today's session. My name is Chris Vantine, the Chief Technologist for the Western Region, Silicon Valley at Red Hat. And I've been with Red Hat for about 11 years, working with strategic partners and customers, primarily in Silicon Valley. They are adopting our emerging technologies around middleware, software-defined storage, virtualization, and containers. And certainly one of the hot topics around Docker and Linux containers is around security. And so today, I'm going to spend some time talking about some of the industry drivers around containers, why Linux containers, a little bit about the technology, also talk about container security and having continuous security in a container-based environment. Feel free to ask questions as we go along. So in terms of the industry drivers, I saw this on CNBC. 40% of the Fortune 500 and S&P in the U.S. will not exist in 10 years. Right? You can either subscribe to that or not, but one thing I think from a technical perspective we've seen is how software is transforming many different industries out there, whether it's automation in the car industry, travel, etc. There's a huge shift being driven by software. And certainly, here's an example of one. Does anybody recognize what this is a picture of? Yes, it's the Tesla automobile factory, right? And software is a big part of the transformation of this factory into an automated, robotics-driven factory, but also the vehicles that are being produced from this factory. There's a lot of software going into these vehicles, and that's enabling, for the first time, to be able to go to a dealer's lot, drive off with a car, and you know that that car will actually get better over time. Right, in 6, 12, 18 months, whether it's improved 0 to 60 times, better efficiency in the electric battery system, or updated applications on the center console. Not only that, but it's transforming and saving Tesla millions of dollars with the ability to deliver software updates to the car over time. We've all read about a variety of different vehicle recalls from many different manufacturers over the days. And Tesla, in some cases, will be able to deliver a software update, saving them millions of dollars from having to pull that car into a dealer's repair factory. And so you can see, what happens if companies rest on their laurels and they stop innovating. Well, the San Francisco taxi industry, a town I used to reside in, is a perfect example. Uber and Lyft entered that industry a few years ago, and you can see the impact it's having on the taxi drivers in the traditional cab industry. They used to average almost 1,500 rides a month. Now they're averaging just around 500 as of a couple of summers ago, and I'm sure it's gotten worse, a decline of 65%. And the software application, the mobile application, was a big part of that, because as an end customer, I no longer had to wonder when the cab would arrive, which way was the cab taking, the long way or the wrong way to get to my destination, or whether the cab would accept a credit card, because it would automatically deduct from my electronic account. And so the ability to innovate rapidly is having a huge impact on industries and companies. And so IT has got to get and remove itself from being a bottleneck to the business so that the business can rapidly introduce new applications to production. And so that's requiring IT to really rethink and shift from a perspective of how they develop applications, the architecture they use, as well as where they run these applications on. And so there's a shift away from waterfall and agile to DevOps so that they can accelerate application delivery, both in a cultural change as well as process and tools. Also, in terms of how applications are developed and architected, moving away from monolithic applications to small composed microservices with APIs so that we can rapidly introduce change with low risk and get things into the marketplace quickly. Also, it doesn't make a lot of sense to run these types of applications on physical infrastructure. It takes a long time to set up and install, or even virtual machines, which are large in size. But a container, which is a much smaller footprint and has lower resource overhead, is a better fit for a microservice that may be only a few megabytes or tens of megabytes in size, and pairing that with a container that is very lightweight versus a virtual machine that may be 5, 10 gigabytes in size. And so we're seeing a shift to accelerate the application delivery, but also improve quality. And so containers are a big part of this problem. And because on the left, you see, in resolving the problem, because on the left side, one of the issues is that you have the business demanding of the developers to produce applications quickly, and they're complaining because on the operations side, they're trying to enforce security standards, security rules, and policies, and so they're slowing down the factory of moving applications from dev, test, into production, because the operations folks are trying to meet those standards that the security team is putting in place. And so what is a solution is, containers are a big part of resolving the friction between the two sides of the house, because they enable the application developer to produce their application with its associated dependencies in a lightweight container image, and then allow that to be run on any type of infrastructure that the operations team can enforce and control from a policy and security standpoint. And so we'll talk a little bit more in detail on how the developers and the operations can get along and remove that friction in the organization while meeting all the security standards. In terms of Linux containers from a technology perspective, containers are all about being able to package an application once and then deliver it anywhere, right? Without having to rebuild it. So package it in development, take that artifact, move it into test it as is. Don't have the testers rebuild the application. Likewise, put it into production as is, and so you reduce the amount of risk and you accelerate the application delivery. And the container itself provides a lightweight, full-blown operating system without having to pull on all the components. Right? It relies on the host-level OS for many of the components. And it has its own isolated process, network, and file system spaces. And containers have been around for quite some time. We had Solaris Zones. It's been in Linux. Google contributed to the kernel many years ago. And it's been there, but it hasn't been quite catching on because it was complicated to use. And then Docker came along and really simplified the runtime with a standard API and a standard format for the image. And so now you've seen huge interest level in containers. And the basic premise of containers is the build, ship, and run. You can build your application using a Docker file. Think of this maybe as a make file for your C application. This is just for any language. It could be an application written in Java, Node.js, Perl, Python, etc. And so from a developer perspective, I can specify a base image to build my application on. In this case, it's Fedora. Right? So the operations team, from a security perspective, can provide standardized base images that my development team uses. Images that do not have security issues because they've been scanned and checked. Once the image is built, you can then share that image and ship it across different environments or different users or groups. And in this case, you have options to store those images in a public registry or a private registry. The challenge with public registries is you don't necessarily know who built that image or what security issues may be in that image. And we'll talk in more detail about the risks associated with that as well. The alternative is to have a private registry. Right, to build a registry within your firewall so you know who is putting images into the registry and what content is in those images. And then thirdly, the ability to run those containers. Right? It's important to have a secure environment where you run those images. The beauty of Linux containers is that you can run it anywhere. Physical, virtual, public, or private cloud. And one of the things with containers, as I mentioned, is that they've come together, the industry as a whole, under the Linux Foundation. They've created an open container initiative to standardize on the format and the runtime. So similar to like a J2E spec where you have a standard around Java and then the runtime. In this case, for Docker, we have a standard file format similar to an EAR or WAR standard on the Java side. And then on the runtime, we have the Docker standard runtime that's been standardized on, and now the industry is going to produce their own implementations based on that spec. And so that provides the portability and transferability of Docker-based images across different environments. And so what are some of the early use cases we're seeing around containers? Certainly around DevOps, so the ability to quickly and rapidly move containers into production. The ability to rapidly always rebuild or build every time you check in your software in a CI/CD environment, such as like Jenkins. But also, it goes hand in hand with microservice. But another big use case we're seeing early on with early adopters around containers, is the ability to take legacy applications that are running on old hardware, and maybe you don't have the source code anymore. Maybe you just don't want to put effort into upgrading that application to a new OS, but you need to be able to run that on the newer hardware. And so you can containerize an application as is and put it on for instance, maybe it's a application running on RHEL 6. You can containerize it in a RHEL 6 base image and then run it on a RHEL 7 host so you get that new hardware support without having to put effort in upgrading the application. Also, we're seeing use cases around availability, real-time scale. So folks are looking like at Spark clusters and the ability to build out these large Spark clusters that have peaks and valleys in terms of demand and usage. And one of the difficult things for them is if it's a VM-based cluster, it's hard for them to keep up with the demand and start up enough VMs to keep up with that demand. And so instead, putting it in a container, which starts up in a matter of milliseconds or seconds versus minutes, provides the ability to quickly increase capacity versus a virtual environment. Also, I call it Diet VM. This is a use case where we have render farms or chip validation clusters that traditionally have not used virtualization because virtualization had too much overhead in terms of resources. And so you look at these clusters today, most of them are running directly on physical hardware. But with containers, because they're lightweight in nature and they don't consume much overhead in terms of network, CPU, or memory, now they can containerize these applications across the cluster and now share the infrastructure amongst multiple projects or teams and applications. And so that's another use case. Infrastructure optimization, with the low overhead of containers, you can get a lot greater density. Some of my customers say about 10x density of the same application when they containerize it. Big data is another use case. As you get these very large data sets, it's very difficult to transfer and not very efficient to transfer all the data maybe to another location. Think of maybe in the research universities where you have a large data set and you have professors and students across the globe that may want to run an analysis on that data. Rather than shipping the data to the different universities, you can containerize your logic and the application, put it in that container, and then ship the container to where the data is. And so those are some of the early use cases we're seeing in the enterprise for containers. Now let's talk about container security. Does anybody recognize some of these brand names? Right, the reason I put these up here is because in the US, these are some leading brand names, and they represent 1 billion data records that have been compromised from a security perspective a couple years ago. Right, and this is a huge impact. When I polled different customers at Red Hat around security and whether there are concerns of risks, here are the key and the top challenges. One was, employees not taking proper security measures, right? Just policies and procedures. 32% said they're concerned about outside breaches. 14% unpatched or unpatchable servers. This is a common issue that I run into with customers on the IT side. And then also internal attack by an employee, right? Shadow IT, and then also the concern around bringing your own device and introducing a known risk into the enterprise. And so when I first joined Red Hat, one of the things I would often hear when security came up with folks in Silicon Valley is like, well, we don't really patch our servers. Right? We have a firewall. We patch our servers in the DMZ, but everything behind the firewall, well, that's okay. Right? So I think those days are long gone, and there are a lot of security issues and risks that you need to be aware of, not just from a general IT perspective, but if you're implementing containers. Right? You need to be aware of the importance of the kernel in a container environment. Right? In a container environment, a single host, you have a kernel running, and that host has a single kernel for all containers. Right? Unlike a VM environment where each VM has its own container. Right? So there's more layers of attack and more layers you have to compromise in order to get down to the host, whereas at a container, if you have a kernel issue, you potentially have open access to all the containers. So you need to be aware of that in terms of patching your kernel, in terms of what kernel you're using as well. Denial of service attacks. Right? You need to be aware that, hey, if I have a container and I don't have a quality of service limitation on that, I could really compromise the quality of service of the other containers on that system as well. Container breakouts, right? You need to be aware of the risks associated with being able to maybe run a container as root. Right? That could have a negative impact of being root on the host or being root in the other containers. Poison images. Right? You need to be aware of what images are you pulling into your environment. Right? What security risks are known in that container image? Where was that container image pulled from? How was it configured? Compromised secrets. So in the container world, you have the ability to pass username, password, and secrets, and you want to be aware of the risks associated, where those secrets are being stored, how they're being transferred. So those are just some of the security risks you want to be aware of. In terms of the container runtime, you have the traditional OS versus the container. So as I mentioned, on the left side, you have a single kernel typically running, and the libraries are shared across all the applications. Whereas on a container-based environment, you have a single kernel being shared across all containers and the hosts, but the individual libraries can be dedicated to each container. So on the right side, I could actually have a container with a RHEL 6 runtime running side by side with a application with a RHEL 7 runtime, and the host may be RHEL 7. So this provides a lot of flexibility to not have to upgrade constantly your application. In terms of the key technologies that are enabling containers, there's really three primary ones. One is, we talked about quality of service. cgroups provides the ability to limit the resource consumption by a process or a container in terms of memory, CPU, network, etc. And that allows you to have many containers sharing the same host and being able to have guarantees around the SLAs around quality of service. And Google did a lot of development over about a decade ago and contributed to the Linux kernel, so very stable and mature. Also, namespaces. So namespaces, such as kernel namespaces, provide the look and feel to a container of an entire operating system, and also provide the separation, for example, and uniqueness of maybe the group ID or user ID in a container versus what's at the host level. So for example, if you're a root user in a container and you hack into the host, that doesn't translate to being root at the host level. And so that's a security implementation to protect you in a container-based environment that's in the operating system. Also, SE Linux. When I talk about SE Linux is providing mandatory access controls to a process on a Linux system. In most implementations I see out there today, most folks disable SE Linux. Well, it's very important in a container-based environment that you have this enabled, and Red Hat provides a predefined policy in your system to easily implement that for you in a container-based workstation or server. And that provides the ability to limit the root of the hack vulnerability. So if you hack into a container and you get out of the container, that process is limited to what it's explicitly stated in terms of what files I can access, even if it's root. So a typical system, if you're root, you can access anything. With SE Linux enabled, you have to explicitly state, even as a root user, what can that process access. And so that provides an extra layer of security in case anything is compromised on the system. So very important to keep SE Linux enabled from a security perspective. Also, in terms of container images, right? So important to understand kind of how container images are architected. They have layers. So on the right side, you can see this particular container image is comprised of a base image, RHEL 7. It also pulled in the Java, as well as the EAP for the J2E app server. And then above and beyond that, as the app developer may install their application or their configurations, it would create additional layers. And so a single container image consists of multiple layers, and this provides an easy way for operations and developers to coincide and not get in the way of each other. In terms of operations can provide a base image for RHEL 6 or RHEL 7 that's containerized, and then the app developer can build upon that. So think about security. The ops team can still own the security, maintenance, and updating of the base image on which the developers are building applications. And so that's a nice way in an enterprise type of environment you can still maintain security. And so it's important to understand, we talked about public registries for Docker images. Well, we conducted a scan of Docker Hub a while back, and it actually showed about 64% of the images had some sort of high or medium of security vulnerability. Right? These are things like Heartbleed or Shell Shock. And so it's very important to know, hey, what are your developers pulling into your enterprise? And the reason that is important is take a look at a container image. On the left side, you have a C application. Then you have a Java, a Node.js, and a Perl PHP. And the little boxes, what it's showing is what components it pulled into the images. So if I'm writing a C application, it's to pull in Bash and glibc. And then the Java application, of course, pulled the JRE in. And then the triangle, what that represents, there's a little number in there, and that represents how many security notifications have been issued for that particular component since RHEL 7.0 was released. Right? So Java, 66 notifications and counting in regards to security issues. So very important to not only be aware of this security when you pull down the image, but over time as well, because more and more security issues are discovered. And so it's important to the organization. You need to have a process and a tool set to be constantly scanning your container images and being aware of the issues that may be in them so that you update them accordingly. And take a look. When you look at the vulnerabilities per package, here's the top 20. Right, where are the security issues happening? Right, if you're running a Java application, well, really the two most important things, kernel and Java, is where all the security issues are. And the kernel is even that more important in a container-based environment. So it's very important, where are you getting your kernel from? Are you patching your kernel? Do you have system and tools in place to address that? And so, what are your options? And these are really the three, I would say, approaches I've seen with customers. One is they do a security by luck. They just have any old distribution out there. It may be end of life. It's not uncommon. Many enterprises have at least a few of these servers somewhere running an old application. Maybe it's just the menu to the cafeteria or something like that. But what I hear from CIOs is that also when they have security breaches, it's usually due to that often forgot system that was very old in terms of their operating system, and it hasn't been patched in a while. Also, another approach is security by firewall, as I mentioned earlier. So there's really no patch management. They rely on the firewall, maybe using untrusted containers, just pulling them down from public repos, and SE Linux is disabled on the systems. And then what we're recommending is really a trusted platform, right? Having a supported distro where you're getting security updates, you have patch management process and tool set in place, you're using trusted containers, and the host is a trusted. Also, in terms of container scanning, you have a process and a tool set, and you have SE Linux enabled. So those are some best practices to address container project called OpenSCAP. So this is a community project around providing a tool set to provide a tooling around compliance scanning as well as vulnerability scanning for your containers, virtual machines, and physical hosts. And so it's all based on CVEs, right? So common vulnerability and exposures. These are notifications that are issued around different operating systems of security issues, right? So if there's ever an issue found, there'll be a release, a CVE released, talking about that Linux distribution or that operating system has a vulnerability. The vulnerability is this, and these components are impacted, or these versions, and you need to upgrade the system to a newer version. And here are the versions that you need to upgrade to. Likewise, there's also a common configuration enumeration. And so this is a database of recommendations around configuration of an operating system to meet security standards. Right? In this example is setting the password to a minimum length. Right? That's a check you may want to do on your system or your container to make sure that it conforms with this. And so with that content, those notifications, that's where OpenSCAP leverages those notifications, the CCEs, the CVEs, and allows you to conduct scans. And it takes that content, in this case, for the Linux distribution. It provides a set of tooling, such as OpenSCAP command line tool. It also can be integrated with the Foreman, which is a data center-wide systems management solution that allows you to scan more than one host. And then when you run these scans, it generates reports. So you can see how your environment scored in terms of CVEs or CCE checks. So let's take a look at some of the use cases for using OpenSCAP. So the first use case is you want to scan for compliance, right? Are password quality requirements set or obsolete services enabled, such as Telnet? Is OpenSSH properly configured? And is /temp on a separate partition? So these are some common checks that you would want to perform on your system to see if it complies with that security policy. And so with OpenSCAP, you can run the OSCAP command line tool, and it will scan the system based on the backend database that has a list of all these checks. And here you can see, disable host-based authentication, disable SSH, etc., and you get the pass or fail result of the scan. You can then go into your web browser and view a report for this particular system, and you can see a more visual breakdown of what passed versus what failed, as well as the priority or severity of them, high, medium, and low. And so this particular system had a 48% pass score. And then I could actually drill down into all the different checks. So I can view all the checks, whether they failed or passed. And then I could select one that failed, and it provides me a remediation script. I can manually run that, or I could set it up to automatically rectify the issue by running this script as well as it scans the particular image. And so that's a nice way to keep your systems compliant in terms of a security policy. Second use case is you can scan for known vulnerabilities. So this is, what RPMs need updating on my Linux system. What is the criticality of the vulnerability? What is the vulnerability? What CVs have not been addressed on this particular system? And so I can go ahead, again, run the OSCAP command, and it will scan the particular system and output the pass or fail on the scan. And again, I can bring up my report in my web browser, and it'll give me a high-level view of the results. I can then drill down and see the individual components that have known security vulnerabilities. So the ones in orange here are failures. And then I can actually update and apply the new patches. Another use case is you can apply it specifically to containers. Is the Docker image compliant? Is the Docker image patched? Is the Docker container compliant? Is the Docker container patched? And so the difference between image and container is image is at rest versus the container is a running instance. So I can check online or offline Docker images and instances. And so here I can pull down the Docker tool set, and I can run the OSCAP Docker command to run it against an offline image on the file system, or in running in the system, I can run it online, and I can provide the compliance scan, or I can do the vulnerability scan. Right? So this is checking for security policy or vulnerabilities. I also have the ability for the security policy to go out and customize that policy for my environment. So I may not want to check all the checks it provides. I may want to limit or target on very specific ones that are applicable to my environment. So there's a Workbench GUI where you can go in and create your own custom security policy. You can run that locally or on remote systems. I can also have this run as a part of my installation process. So there's the Anaconda, which is the builder for a Linux distribution installer, and you could actually run this as a part of the installation process, so it's automatically doing the scan at build. And just this shows you the results of a system built without running the check versus running the check. So you can see that's even out-of-the-box systems are not conforming necessarily with a security policy. And so this is a good way from day one to have a system that's compliant. Also, I mentioned Foreman. This is the ability to run the scans across data centers and across a cluster of servers versus a particular individual host. And so this integrates with OpenSCAP underneath the covers and shows you more of a dashboard view across your entire infrastructure. Now, we talked about scanning, but in this move to containers, it's usually associated with moving containers rapidly from dev test into production in a DevOps or CI/CD environment. Right? So in that type of environment, it's important that you have the ability to do automated builds and automated deployments. Because in a container environment, it's highly unlikely you're going to go out and patch or update individual containers. Our recommended approach is actually to rapidly rebuild your application with the updated components and dependencies, and then move that through your DevOps or CI/CD pipeline from dev test into production, and then deploy that new version into production. So a little different approach than probably maybe how you're managing your virtual or your physical infrastructure. One of the key things that in order to be successful with that is to automate your builds and automate your deploys. And so with that type of flow, there's some key components that need to be a part of your environment from a technology perspective. First off, you have your containers with Docker for the runtime and the image format, but how do you manage images at scale? You need a scheduler and an orchestrator to manage the application and its deployment across a cluster of systems. And that's where Kubernetes comes into play, or using something like Ansible to do orchestration. And so Kubernetes is a cluster management solution from Google that they open source based on their years of experience and innovation around containers for their own data centers. And so they open source it a while back, and Red Hat is working with Google and bringing the enterprise capabilities and feature set to the upstream community. And so this is for application container management, the ability to automatically deploy, update your containers in production. So this provides that ability to confidently be able to update versus having to patch the individual containers. And so the example of Kubernetes, what it can do is you can actually deploy an application. And this is just showing you the GUI cockpit from the Red Hat Atomic Host, which is a container-optimized operating system based on RHEL. And this shows you how you can deploy the application. This has a front end and a back end. It automatically takes care of the IP address for you. I have one instance of the front end, one instance of the back end running. I could pass my secret, my username, password, so the front end can talk to the back end automatically. So it's very easy to deploy a containerized based application. But one of the key things is how do you upgrade that application once it's out there? So there's a security issue in version 1. How do I upgrade my environment quickly to 1.2? Because I'm not going to go out and patch all my containers. These containers might be short-lived, or there may be thousands of them. And so what I can do is actually trigger an automated rebuild in my development environment because I got a security notification that the base image had a vulnerability. A new version is available. I could be watching that stream or that registry, and my Jenkins instance, for instance, could be automatically triggered to do a CI rebuild of taking that application, pairing it with the base image, and producing a container image. And so what I could do is I have version 1 out there. That triggered a version 1.2 rebuild. I went ahead and redid the CI testing, and it produced the Docker image. I can then automatically deploy that new version out into my cluster, and Kubernetes would automatically update the load balancer for me. And so I can easily move from one version to another. Right? Automated, deploy. This is how I would address a security issue in production versus going out and using a patching tool to update a component within all the containers out there in my environment. I would rather rebuild, redeploy, but I need automation in both the build and deploy process to really make this a reality. But once you have that optimized software factory for building and deploying applications, it's very powerful because I can not only roll out security updates, but I can confidently deploy new applications when the business needs it in a matter of minutes versus weeks or months. And so that's a key component of having a secure environment. Also, I talked about having continuous or automated builds, and integrating security into your automated build process is very critical as well. So there's a Jenkins-like build pipeline that a developer may be viewing in a dashboard. So you have your build 1, build 2, build 3. But what you may want to do in a containerized-based environment is add a step or add part of that build process is the OpenSCAP scan to your Docker image. Right? You want to scan it during build time, during your CI testing, to see if it complies with your security policy. Check to make sure it doesn't have any known security vulnerabilities. So if you integrate this into your build process, that's how you can have this continuous delivery of secure containers and be able to update whenever there is an issue in terms of security and be able to automatically deploy that. So this is an example. This shows you the build pipeline in our OpenShift solution, which is built on Docker and Kubernetes and provides also a developer view, not just operationally. And so that's the ability to provide automated builds with security. So just in summary, only run container images from trusted parties. Container apps should drop privileges. Right? Many containers out of the box assume and run as root, so you need to be aware of that. Also, host operating systems matter. Right? Your kernel is a key component. You want to make sure you have processes and tooling to update them. Be sure to apply kernel security fixes. Do not disable SE Linux and container-based environment. Red Hat, we provide a SE Linux policy for Docker, and certainly don't disable that. There's a lot of security risks if you do. Also, in terms of examining container images for security flaws, have a process, have some sort of tool, not only in your production environment, but also in your build process. Great. Well, I want to thank you for attending today's session, and then feel free to ask any questions. I'll be around after the talk as well in the hallway. I'm also available via email or LinkedIn. Feel free to reach out, and I hope to hear from you with any of your questions. Thank you so much. Questions? Yeah.
In terms of looking at vulnerability scanners, is everyone still using the same database of common vulnerabilities?
Right.
I'm sure that's not the differentiator. It's just being able to plug into a database of vulnerabilities. That's the important part.
Right. So in the U.S., the NIST organization from the government issues CVE, issues CCE, and those are publicly available. The difficulty has just been having tooling that leverages that content and data, and so that's what the OpenSCAP project is doing, is providing some simplification and some automation to be able to take that data and actually apply it and scan your systems or containers. The OpenSCAP works for not just for Red Hat distribution, but other distributions like Ubuntu, et cetera. There's also other tooling that can interface with the back-end database. Yeah. In terms of and then also in terms of our distribution, we provide a security guide that's specific to our distribution. So that is some of the unique content that we provide. Yeah.
Hi. We actually, to scan our applications, we try using Black Duck, which is also a competitor of OpenSCAP, right? And the problem with Black Duck is that it does not identify statically linked components. So let's say I've got a big executable with statically linked OpenSSL, which has the heartbleed problem. Mm-hmm. Black Duck will not identify that. But is it possible with OpenSCAP or any other scanning tools which are out there?
So the recommended process is to install with RPM, and that's what it's using. It'll scan the container. So if you're installing your own applications outside of the regular system, then you're going to have your own scanning type of process for that, right? It's not doing a binary scan. Yeah. So if the developers build their own thing, they also need to be aware of the security and own the security for that too. Right?
You mentioned that it sounds like there's a lot of images in the public in Docker Hub at the moment, by the sounds of it. Do you think there's anything that, since people are kind of using those as the base for a lot of their experimentation with Docker, do you think there's anything that is being done or could be done to kind of deal with that?
Oh, sure. So, I think the movement towards private registries for an enterprise makes a lot more sense. I don't think many organizations are just randomly pulling down software publicly and putting it into production today, hopefully. And so having a best practice of maintaining some sort of internal repository that has some sort of checks and balances in terms of what your organization is using is important for what's going into production. In terms of fostering innovation, I think being able to access public things and having that in a sandbox environment is important so that you do accelerate innovation. And not limiting your developers from having access to the latest and greatest. So I think there has to be a balance. Okay. Any others before we break for lunch? You have a question? No? Okay. Great. Well, thank you very much for attending, and feel free to reach out afterwards if you have any questions.